Hey there, welcome to dotnetFlix. Edwin?
Hi.
So we are going to talk about service mesh.
Yes, service mesh.
So what's a service mesh?
Yeah, I will get into that a little bit later, what a service mesh is, but basically it's for, getting grips on your microservices application.
Okay.
And I have a couple of slides to do an introduction, and then we're going to do some demos in which I will show you how to implement a service mesh using Istio.
Okay.
And that is a tool that runs on top of Kubernetes,
Right.
which uses containers. So it's lots of stuff going on here, and I will do a short introduction of that.
Okay,
So,
cool. Well,
yeah.
Let's dive right in.
Yeah, so sessions is called How to Get a Grip on Your Microservices System Using a Service Mesh. So that's pretty cool. This is what I'm going to do today, short introduction. Then we're going to look at a service mesh implementation using Istio. And then I'm going to look at basically the features that Istio gives you as a service mesh, like monitoring, scaling, things like Canary releasing we're going to look at, and also testing some resiliency. So these are the demos I'm going to do.
Cool.
So without further ado, like I said, containers. Containers is the way to deploy software nowadays. You see lots of people already working with containers. We have lots of tools, and also, for instance, in Azure, you can just run containers, and all that kinds of stuff is, it's basically getting commodity, so that's cool. And you see lots of people already creating services, microservices applications using containers that are connected together. And
Right.
this can get pretty complicated. So we see people looking like this. How am I going to get a grip on this when I have several containers running? I have networking, I have all kinds of stuff going on. What am I going to do to get a grip on that? Well, that is where Kubernetes comes in at first. So Kubernetes is a container orchestrator, and it's been around for some time. It was created by Google, and it was open sourced. And well, Kubernetes can help you to get a grip on, setting up a microservices application and connecting all the services to each other over networks and stuff like that. That's in a nutshell, of course, because
Right.
Kubernetes is very vast and very configurable.
And it's just one of the choices for a container orchestrator,
Exactly.
right?
Yeah, yeah, and it is the go-to orchestrator for now. So
Yeah. It's the de facto standard, right?
yeah, you see, the industry or the community basically all use Kubernetes. And you also have, for instance, in Azure, there's Azure Kubernetes services. And everything that I'm showing today runs on my machine, on Docker for Desktop, but it can just as well run on AKS, for instance, in Azure.
Okay,
So that's,
cool.
that's pretty cool. Or another Kubernetes provider. So when you look at Kubernetes, and like I said, there's lots to tell about Kubernetes, but I will just dive in. What are the objects that you can use within Kubernetes? And first of all, we have nodes. This is basically the machines that you run your Kubernetes stuff on top of.
Right.
So it will run containers and stuff like that. So that's the first one. Then there's a thing called an ingress, and that was something that you use to get traffic from outside your Kubernetes cluster into your cluster.
Okay.
So that's your gateway or whatever.
Your endpoint to your application.
Endpoint to your application, yes. Then there are services, and those you can see as endpoints within your cluster, within your application. So
Okay.
every service, microservice within your application should have a service so you can connect to it. So it's also an endpoint, but then within your cluster. Then you have deployments, and that is where you actually deploy the code that is running. And within a deployment, you have pods. And that is the smallest unit of deployment within Kubernetes. So you always roll out pods, and pods contain container or containers.
Right.
So you can run your containers, your Docker containers, for instance, inside of a pod.
And if you run multiple containers inside a single pod, they are co-located, right?
They are co-located, yes, and they can also talk to each other over some kind of an internal network within the pod.
Okay,
That is very important if we look at a service mesh, because
Yeah.
that is what is used to get this service mesh up and running. But important, like I said, pod is the smallest unit of deployment. Like you said, they're co-located. And then sometimes you need multiple pods, because if you have a service that contains one container, but you want to have several instances running within your Kubernetes cluster, you can use a replica set. And a replica set, you can say, okay, this is a pod, it contains my search service or whatever,
You just scale it out.
and you scale that out into multiple instances. Cool. So what does this look like? If you look at, this is a sample of a 2-node cluster that I have up and running. And this is just a diagram, of course. But what you can do, if I have a search service, like I said, this is a replica set of one pod, and I can just roll that out onto my cluster using a deployment. And then if I want to call this service, I create an endpoint, which is a Kubernetes service, in this case the search service, and I create an ingress to make sure that people from outside my Kubernetes cluster can call this service.
And in this case, is it just the Kubernetes orchestrator that decides that it needs to run that deployment on node 1?
Yes, because you don't actually choose which node you want to run on. That's the nice thing about Kubernetes. That's a good addition. You have a couple of nodes and you want to run, services and pods. And Kubernetes will apply this to the cluster, and it will roll out the deployments to a node.
Right.
Yeah. And there's all kinds of ways to look at that and to monitor that to know on which node something is running. But basically, for you, it shouldn't matter.
Okay.
Yeah. Of course, I can also have a deployment, in this case an indexing service, which has multiple pods, so I scaled it out.
Yeah.
But it doesn't have a service. It is just running, and it's a background process that indexes some stuff. You don't always need to have a service.
Okay, so this is just a worker process which doesn't have an API or something like that.
Exactly.
Exposed.
Yeah. And then on the other node, we have a product service and a product service v2. And this is also very nice to do with Kubernetes. You can actually do upgrades, have multiple versions of a service running, and Kubernetes can help you with doing, for instance, zero downtime deployments.
Cool.
And Istio will even add on some capabilities to do stuff like that, which we will see in a minute.
All right.
And I can then have one service, the product service, and for instance, load balance the traffic coming in for these servers over version 1 and version 2.
Oh, very cool. Yeah.
And this is all kind of stuff that you will configure on Kubernetes.
Nice.
Like I said, it's all nutshell stuff because there's lots of stuff going on, but these are the basics. So how do you configure a Kubernetes cluster? So in this case, I have a cluster up and running. This is not something that is easy to do, get a cluster up and running. But you could, for instance, just roll out an AKS cluster, Azure Kubernetes service, and they will do lots of the heavy lifting for you. So I have a cluster up and running. And for the demo in a minute, I'm just running it on the cluster on my machine. So on my local laptop, I have Docker Desktop installed, and you can just check a box. And then you have Kubernetes running on your machine. So that is
that's Minikube.
That's a small cluster, one cluster machine, of course, because I only have one machine. Configuring a cluster, if I want to do something or roll something out onto this cluster, I will create configuration files, which are YAML or JSON files, in which you describe what you want to roll out onto the cluster. So you create deployments and services and stuff like that. We will look into that a little bit later. And then there's the Kubernetes CLI, and you will just apply or create, but you can just apply these configuration files. Those will be sent to the Kubernetes API, and then the cluster will be, all the stuff will be rolled out onto the cluster.
Okay, and that's basically desired state, right? So I can change a couple of things in the template or in the YAML file, reapply that, and only the changes will be made.
Yeah, and it will check. If you don't change anything, it will also not reconfigure anything. Right. It will just say, okay, I already have the desired state, so nothing needs to happen.
Cool.
Yes. So today I want to show you some capabilities of Kubernetes and, in a moment, Istio, using my Pitstop application.
Cool.
This is a very simple application for a garage, so a vehicle servicing station. It is a very simple application. It just has a couple of services. There's a web application. It's just an ASP.NET Core web application. And it basically uses 3 APIs, Customer Management API, a Vehicle Management API, and a Workshop Management API.
Okay.
And there's also, I'm doing some stuff here with events, so there's also a message broker, but it's not really important for today. But it's also included in the application.
And so these are all separate microservices in separate Docker containers, right?
Exactly. Everything is in a single Docker container.
Cool.
Yeah. So if you look at the Kubernetes deployment of this application, this is what I'm going to show you in a minute, this is what it looks like. So I have a web application that uses a web app deployment. And this web app deployment uses the Customer Management API, Vehicle Management API, and Workshop Management API services to talk to eventually the pods and within them the containers that run my application.
Right, and I guess you've also got an ingress object set up to make that web application available to the outside world, right?
But I won't show that now, but that's all up and running. And what I have done, if I have created this so that the web application service is available through localhost.
Okay, cool.
Yeah, so that's something that I did. And in this case, you already can see that for my workshop management, that's the most important service because that is where most of the management goes on. I have 2 instances. Yeah. So this is what the application will look like. So without further ado, let me show you how to do this. I will go to my Visual Studio Code, and this is where I have the entire application. And I have a single folder, the K8S folder. This is also sort of an acronym that is used for Kubernetes.
Right.
And I have all kinds of scripts in here. And I will show you one of the scripts, for instance, the web application script.
There's a lot of YAML there.
There's a lot of YAML there, and I will show you a little bit more in a minute. But this is the first one. Let me close this one. So this is the YAML file, and it basically describes what needs to happen. So in this case, it's a deployment.
And what's the scope of this YAML file? Is this only for your web application?
Yes, this is only the web application.
Yeah, okay.
So that's why I have lots of files here. So I've created a separate file for all my different parts of the application.
Right.
And in this case, it's a deployment, and this is very important. You use labels a lot within Kubernetes because this is how you can designate certain services within your application. You can give it a version, and then lots of concepts within Kubernetes. If you need to select certain machines, for instance, to load balance stuff,
right.
you use labels.
Okay.
So you say, I target these labels, and then Kubernetes will find out which machines or which pods apply, and then use this for load balancing.
And you can choose your own labels, or are they all predefined?
No, you can just choose your own labels.
Nice.
For Istio, there are some labels that you need to include. Well-known labels, but this is something that you can do for your application.
Okay, cool.
This is also very important. Within Kubernetes, you can create namespaces. So you can just group stuff together, and that's very nice to do.
So it's also nice for multi-tenant scenarios.
Exactly.
Like that.
Yeah. So and everything is created in the Pitstop namespace in this. Well, and then I describe, and I won't go through the entire file here because there's lots of stuff going on, but I will define basically what my deployment should look like. And here I can specify the container that I need to run inside my pod within this deployment. And I define that the replica set here only contains 1 instance.
Right.
So this is where I can configure my replica set. And then there's basically a template, and I specify that, for instance, this is the name of the container image that I need to spin up later.
Right.
I know I shouldn't have used latest. That's not a best practice here, but because this is a sample application, that's no problem. And this is also very important. I say that if I already have this image on my machine, you don't need to pull it from a registry. If I don't specify this, it will always get the latest version from the registry.
Okay.
But if I already have it on my machine, that is not necessary.
So where are your containers stored? Is this in Docker Hub?
Yeah, these ones are in Docker Hub, but you could configure every Azure Container Registry or a local registry, whatever.
Right.
You could use a private registry. So this is the deployment of my web app. And then I also want to make sure that people can call this web application. So I also define a service. And what I did, you can use this one to separate different items in one file. I could have created separate files for that. But in this case, I want to have the deployment and the service in one file. So here I define a service. I also give it some labels. And then I create a load balancer for this one. And I will run it on port 7000. And in this case, because my type here of the service is load balancer, this will also make it available on localhost on port 7000. So this is why I can access my application. And for all the items within my application, so for all the APIs for the web application, but also a SQL server is in here and a RabbitMQ, all that stuff is being spun up. And what I can do is start the application now and make sure that it runs on my machine.
Cool.
Okay, so now I will show you how to start this. I have created a script because I could apply all these files individually, of course.
Right.
But what I've done, I've created a PowerShell script that will start all of them. And this is what it looks like. I just do kube control, which is the Kubernetes command line
CLI.
interface, the CLI, apply, and then with -F, I can give it multiple files, and I will just give it all the files that I need. So I create a namespace, I have some secrets going on here I won't go into, RabbitMQ, log service, but you also see the web app. And what I did here, I can start this just on vanilla Kubernetes, and then I don't give it anything on the command line. But when I give it -mash, it will append -istio behind the name of the file. This is my own trick of starting this.
Right. Yep.
Because in a minute we're going to look at Istio, but I will start them with the mesh already for the demo. So what I can do now is I can say start all -mash, and then it will go and start all this stuff on the Kubernetes cluster on my machine. And what I will do now, I will quickly go over to the Kubernetes Dashboard. This is a sample, default dashboard that you get with Kubernetes. You can see here that I have multiple namespaces, and one of which is Pitstop. And when I look at an overview of this one, and I refresh this, I have to relog in because my token was expired. But if I go to the overview of the Pitstop application, then I can see what is going on here. And what you can see here is that it's starting up all the stuff. So deployment's going on, it will create replica sets, it will create pods, etc., etc.
Cool.
And it will eventually start containers.
Right.
Well, one of the services failed. This is by design because it cannot connect to the SQL Server. This is some resilience testing that I'm doing. But if I refresh this now, I will probably see that everything is up and running. Yes, and we're 100%.
Nice.
And there's lots of stuff you can see here. For instance, you can see all the pods that are running. For instance, my web app is running here.
And this was pretty quick, but I guess all those containers were already available on your local machine,
Yes,
right?
yes. All the images were already here, so it can just start the containers and it will start up. Well, I can see all kinds of stuff here. And I can even go to, for instance, the replica set. So I'm diving into web app, my deployment, the replica set, which has a pod. I can go to the pod, and I am now on the lowest level, and I can even, for instance, see the logs of the application. So here I can see that this is just a basic ASP.NET web application.
Just the output from your container.
This is just the console output, yes.
Very nice.
I can do that. I can even do exec here and just SSH into the container.
Oh, nice.
So that's pretty cool, and I can do all kinds of stuff.
Like an LD.
For instance, yeah. I need to create an alias for that, but it was ls. And here you can just see my ASP.NET Core application being dropped into the container. So this is up and running. So let's see what the application looks like. I go to localhost 7000, and then I got access to the web application.
Cool.
And I will do a quick demo of this amazing and very intricate application. I can register customers.
It's highly sophisticated.
Yeah, this is just CRUD to the max. I can register vehicles because, yeah, well, basically we're a garage and we need vehicles. And now I'm creating an Opel Astra for Mr. Piet van der Veer. I register that. And then I can go to my workshop and say, for instance, well, Mr. van der Veer will come in this afternoon at 3. It will take me about 2 hours, and I will do change the tires on this vehicle. So it's not a very intricate application, but this is what's going on. What I can also do now is, because this application is running on my machine, for demo purposes, I will start a load test, which will just start hitting my web application on the different items. So it will just customer management, vehicle management, etc.
Cool.
So now let's go back to the presentation to show you what's going on here, because I actually started now this application with a service mesh.
Right.
And I want to show you what a service mesh actually is. So basically, a service mesh provides you a transparent and language-independent way to automate cross-cutting concerns. So I'm just reading this slide here, but this is actually what it does.
Well done.
Yeah. And it will basically do all the communication between the services within your application. The service mesh will help you with this communication, and it will deliver you all kinds of cool features like intelligent routing, monitoring, stuff like circuit breakers and timeout checks and stuff like that. The pattern that you use for this is the ambassador pattern. So
right.
It basically introduces two parties to each other and then makes sure that they can talk to each other. And if you look at the implementation of it, we often call that a sidecar pattern.
Right.
And if you think back about what Kubernetes does, within a pod I can run multiple containers, and these containers can talk to each other over the local network.
Right.
So it is a very nice way to implement that. So you just deploy an additional sidecar container within your pod, and then all the communication from your service goes through this sidecar container.
Okay, very cool.
And you don't have to do anything for that because Istio can do that for you. So this is what it looks like in a schematic overview. So I have a pod, in this case my web application, talking to two web APIs. And what happens when I...
So this is like the before situation.
This is the before situation, right? Yes. And when I add Istio to the mix, or a sidecar implementation, but in this case I've used Istio, this is what it looks like. And this service mesh implementation will make sure that all the communication goes through the sidecars.
Yeah, very cool.
And there's a lot of cool stuff going on there because I can now, from a central place, configure all these sidecars. This is basically a proxy that I can configure. So I can configure traffic management, security, all that kinds of stuff, but also receive telemetry.
Right.
Because all these sidecar containers start communicating with this central location, and this is what you call the control plane.
Cool.
And from your control plane, you can configure everything, and everything that goes on within your application will be sent back through telemetry.
You can really see the traffic flows between your services.
Exactly.
And what I also like about this pattern is that your sidecar that stores your cross-cutting concerns is so independent from your own code.
Exactly.
So that could even be written in different languages.
Exactly. Yeah.
Very nice. Yeah.
So this is what it looks like schematically, and Istio is the tool that I have used to implement this. So let's take a little dive into Istio.
Istio is open source also.
This is an open source tool, yes. And at this moment, you have a couple of tools that can do this. So for instance, Linkerd or Console. Right. They all have some service mesh capabilities. But Istio, for now, is the one that has the most elaborate set of features. Okay. So I've picked that. And this is a picture that I got from their website, and this is basically the same picture as I drew just now, but this is the Istio implementation. And the nice thing about Istio is that it is a collection of other open source tools. So Envoy, for instance, is a proxy that is well used out there in the industry. Right. That they have used that to implement the sidecar. Cool. And they used Mixer, Pilot, Citadel. Those are all open source tools that have a specific well, this is basically microservices. They all have a specific goal in life. And for instance, Mixer is the one that pushes all kinds of policies into the sidecars and gets all the telemetry back. So, how do you inject Istio into your container? So, this is how that works. We have this configuration file, the Kubernetes configuration file.
Just another YAML file.
It's just another YAML file, yeah, and it's just another command line interface. Right. So the nice thing about being a command line interface is that you can integrate it very easily into, for instance, a DevOps pipeline. Yeah. Because it's all command line. Well, in this case, I use the Istio control command line interface, and I say kube inject. Okay. And it will then basically get my Kubernetes file and inject the necessary markup or YAML to create the sidecar pod into your Kubernetes cluster. Okay, so it will
just add all that config to your own YAML.
Exactly, yeah. And the nice thing about Kubernetes is that it works with resource definition, custom resource definition, because Istio has something like a sidecar or a virtual service. And those don't exist in vanilla Kubernetes, but you can add these to Kubernetes. Okay. And that is what Istio does. It adds custom resource definitions.
Custom defined Kubernetes objects.
Exactly, yeah. And then you can use these, and then this command line interface will inject the necessary Istio stuff to make sure that it starts running. All right. So if we go back to Visual Studio Code, we looked at the YAML file for the web app. This was pretty short. And if I look at the web app Istio version, then you can see that lots of stuff gets inserted here. And you already see proxy, sidecar, so there are some arguments. We see all kinds of stuff that Istio added. You can also see, for instance, this is the Docker container or the image that it uses for the sidecar. So all that stuff gets injected, and then the service is just the same service, but this is what is necessary to make sure that my sidecar gets added to the YAML file.
Is this all default, or does it always inject the same stuff, or is that dependent on some other configuration?
It can be dependent on some other configuration because it will read the Kubernetes file and inject the necessary stuff. So it depends on what you have inside your Kubernetes file. By the way, I'm not showing the content of the files, but everything is available on GitHub. I will have a link afterwards. So cool. So this is what I did. And by doing this, I can, if I now run my cluster, and if you can remember, I did dash mesh. So I used the dash mesh YAML files to start up my cluster. They are running now with the sidecars. So what kinds of capabilities does this give me now? Well, first of all, observability.
Right.
Everyone knows if you build microservices, it is very important that you know what's going on within your microservices cluster.
Definitely.
You could have hundreds or even thousands of microservices, and you need to know what's going on. Well, there's a very elaborate set of monitoring tools for logging, tracing, and monitoring. So first we have Grafana, which is a very elaborate dashboard for all kinds of metrics. We have Kiali. This will give you some insights into your topology, your network topology. Jaeger can give you end-to-end tracing capabilities, so you can trace a call through your entire network setup. Yeah. And just by, you have to do something for that in your software, because maybe that's important to tell you right now, that my application, my Pitstop application, I created for Docker, and I have changed nothing in the code.
Okay.
I created Kubernetes files, I injected Istio, and it does all this.
Cool.
I'm going to show you. I didn't have to change any code, but for Jaeger, for instance, you have to ingest and propagate some HTTP headers. There's some correlation tokens, but then it can give you entire end-to-end tracing. And all this is also powered by another open source tool called Prometheus.
Right.
Yeah. So let me show you what's going on here. I already showed you the Kubernetes one. So this is the default Kubernetes dashboard, but this is Kiali. And Kiali is running in the back, and like I said, I started a load test. So my application...
Kiali is just another Docker container running on your local Kubernetes cluster, right?
Yes. You have to enable
Docker
it.
Docker containers all the way down.
It's Docker containers all the way down. Yes. And what I can do now, and this is pretty cool, I can load a graph of the application that's running here.
Nice.
And because Kiali knows about the Envoy proxy in every container, or in every pod, I must say, it will get all this telemetry through Prometheus, and it can show you these kinds of pictures. So for instance, I can say, give me also the service nodes. And give me, this is for demos, of course, pretty cool, give me traffic animation. So I can see the traffic flowing through my application, real time.
Cool.
So this is pretty hefty stuff. Like I said, there are lots of dashboards. So Grafana is another dashboard I won't show right now, but it will give you much insight into CPU, request times, total load, traffic, all that kinds of stuff.
We should do a different video about it sometime.
Probably.
Yeah.
So that's the first one. Second one is scaling. I won't show a demo of that right now, but as I told you, you could, for instance, say I have 2 instances of the Workshop Management API running, and I want to have 3 of them. There's just one command. I will just change my replica set from 2 to 3, and then Kubernetes will make it so, and we'll just create another pod. We'll start, and we'll make sure that traffic gets load balanced over.
And that's not very specific for a service mesh or Istio, right? That's just Kubernetes.
This is just Kubernetes. Yeah, that's out of the box. So I won't show any demos of that. What's more important is intelligent traffic routing. So what I want to do now, I want to introduce a V2 of the Customer Management API into my application.
All right.
So what I can do now, I go back to Visual Studio Code, I go to PowerShell, and I have a V2 file, like I see here. This is the V2 Istio file that I will use right now. And like I said, kube control, apply. I want to apply a configuration. I give it a file, and I want the Customer Management API V2 Istio. And now it will create another deployment, and it will be added to my Kubernetes cluster. So when I now go back to Kiali, in a moment this will update, and I will have a second version of this application. So we will get back to that a little bit later.
So you've deployed a V2, but it's behind the same servers, right?
That's what I want to tell you right now, because I haven't created a routing to this service.
So right now it's running in Kubernetes.
Yes.
But there's no traffic coming in yet.
No, because what I'm showing you now is the servers for the Customer Management API. So this is one service.
Yeah.
And what I've done, like I told you, you select them based on labels. So I've selected everything that has system Pitstop, customer management API, V1.
Yeah.
So my traffic
is still being routed to the V1 version of the
V1
container.
version. Yes, totally. And what I want to do now is if I go back to Kiali, maybe it's already in there. There it is. That's version 2. And I have to do a switch here. Let me see if that's... Yes. And now I can see that the customer management service is coupled to two deployments, the V1 and the V2 deployment, but only traffic flows to V1.
Right. Cool.
And what I now can do, for instance, is I want to introduce traffic into this V2 service.
Right.
But I don't, maybe it's broken. I don't know what V2
probably
is
is broken.
It probably is broken because I created it. So I want to give it some traffic and then monitor it. But I don't want my customer management API service or the web application calling into that service to know anything about it.
Okay.
This is called mirroring within Istio. So what I've done, I've created in this case a destination rule. This is a custom resource definition for Istio, as you can see here. This is an Istio thing. This is not Kubernetes.
Like
I
the
say
alpha tag there.
Exactly. Yeah, this is all still alpha. It is for customer management API within the namespace Pitstop, and I say this has two subsets, version 1 and version 2, which will, based on labels, like I said, everything happens with labels, will create a V1 and a V2. So this is a subset with both versions in it.
Okay.
And then what I can do is create a virtual service. This is also an Istio thing. And I will say, our destination host is customer management API. I want the subset V1 to receive 100% of the traffic.
All right.
But I want to mirror all that traffic to V2.
Okay. So
yes?
this is not a real Canary release scenario where you would...
we will do that in a minute.
Okay.
Yeah.
So this would be just like shadow running.
Dark releasing.
Yeah.
This is a dark release.
Okay.
So what I can do now is I will apply this file. Apply. Oh, if you can, still need to type. If you, that's a bit
darn it. So this virtual service that Istio introduces. Were you already using that with the V1?
No.
Or do you now replace the existing service?
It's basically an overlay, which you can also see. If I look here, with the customer management, you saw we didn't see this appear, but this is now appearing here, that it has, if I select the customer management API, and this is the nice thing about Kiali, it is aware of Istio, it says has virtual service.
Ah, okay.
And the other ones don't have that.
It's an addition to the service.
It's an addition, it's just a sort of an overlay.
Nice.
And what you see now, that still the traffic is only going to V1 because the Kubernetes service that's underneath the virtual service still has this selector.
Right.
So it's only going to V1. So now I'm going to say, okay, I have mirrored traffic to V2. I'm now going to make sure that the version also includes version 2 in the traffic load balancing, because else it will not
because
get any
otherwise
traffic.
Istio could never route to it.
Exactly.
Right?
Yeah. Okay. I will change this. I will remove that. I will comment out that V1 and then reapply. And this here you can see that it is.
By commenting out, you're not filtering on the version label.
Exactly.
So everything that's
V1
called
and
Pitstop customer management API will be included.
Yeah. So I will just reapply the service, and as you can see, this is just idempotent, or it is desired state.
Right.
It will make it so. And then after a while, we will see that traffic starts flowing from V2. It will actually do SQL Server calls because it actually gets traffic, but it will not go back through the service to the web API. So my client that is looking at the web application will not have any knowledge.
Because it's mirroring.
It's just mirroring, yes.
Yeah.
And what you can now see is that my V2 is actually doing stuff. So my service is getting traffic. It will do stuff to the log server. This is, by the way, a link that I haven't done anything for, but it just recognizes that I do HTTP traffic to a log server, then it will show it in my telemetry. And it's doing stuff to my SQL Server. But you don't see that an arrow back to the service or to the web application. So it gets traffic. Yeah. If I would now go to Grafana, I would see actual calls being made to this service, but I don't do anything with the response.
Yeah, so that's also why there's no arrow going from the customer management API to the V2, because it's not a real traffic lane, it's just mirroring of the V1.
Yes. Yeah. And now, like you said, you could now say, okay, I don't see any error, so this probably works. Maybe I will Canary release this V2.
I'm not convinced yet.
Yeah, but that's why we do this. So What I do now is we do the same thing, but instead of mirroring now, we will say that, okay, give 90% of the traffic to V1 and 10% of the traffic to V2. So not everything load balance 50-50, which is default, but I want to give some weight to that.
So we won't break the application for everybody, just 10% in the worst case, right?
So I will just cube control apply min f this canary one. And one thing to notice here is that the name of this virtual service is Customer Management API, which is the same of the mirror virtual service. So I'll overwrite this one.
Right.
I had some bugs in here that I had two services with different name, and then they both exist, and then you get conflicting stuff in there. So you have to think about that.
And so they both get executed.
They both get executed.
Do their destination ruling. Yeah.
Exactly. So now I've created it with the same name. It will override the virtual service, and it will then include the actual V2 service in the traffic. And I can show you also that then the web application can also get V2 functionality. So in a moment, we will actually see an arrow appearing here, and traffic will actually be routed through V2.
Cool.
And if I go now to my application, if I go to the customer and I will go to the details of the customer, the V2 version will actually give me some loyalty information of the customer.
Okay.
So if I now start refreshing here it is. So in 10% of the time, I'm just refreshing now. Here you go. So this was an actual call to V2. I get loyalty information in the response, and I will show that in my application.
Very cool.
So my application is multi-version aware. That's something you still need to do as an application designer. But this way of deploying it is, of course, very cool.
It's very safe.
It's very safe, yes. So without further ado, this is all that I wanted to show you about Canary releasing. And as we see here now in Kiali, there's actually traffic flowing all the way from the web application to the customer management.
Nice.
Which leaves me with one last demo. So this is what we did. We just Canary released it, 90 and 10%. This is what we just implemented.
Right.
Then there's the last thing I want to show you, chaos engineering.
All right.
Because we do software-defined networking, we can do all kinds of funky stuff and see how our application reacts. So, in this case, in my web application, I have some resiliency code. I created using Poly with resilient transient error handling. That if it calls a service and it gets a timeout or an error, it will just retry a couple of times. And I want to test this.
Okay.
So what I'm going to do is chaos engineering. I want to test the resiliency of this application. And I'm targeting the vehicle management API service.
Okay.
And what I want to do now is, everything is okay. I don't want to create a bug in my service, because then everybody would have problems with that. But what I do is I just say, in 25% of the time, just give an error 500.
You would do this just in production?
In production, because we're all Netflix, we can all do this.
Sure.
You know, the Simian Army stuff that Netflix does with the Chaos Monkey. This is basically how that works, but you can do it on an infrastructure level. I don't have to change anything in my code.
Yeah, cool.
So what does this look like? Well, it's getting a bit boring, but I just have a YAML file for the vehicle management. YAML. And this is how I do it. I have a virtual service. We've seen that one before. And I'll just say, I want to, on HTTP level, I want to include a fault, and I want 25% of my traffic to return an HTTP status 500. And now the only thing I need to do is just say, well, like I said, it's getting a bit boring. Cube control, apply, and just apply this file. So the virtual service gets created.
And your web application, so in a quarter of the request, it will get back the 500.
Yes.
And we'll use Poly just to keep retrying until it gets a 200.
Exactly. Yeah. So my application should stay up and running. Yeah. Like you see, there's also now a virtual service created for the vehicle management API, and in a moment we will see these errors occurring in 25% of the request. Here we go.
Oh, there we go.
So first it says, this is a bit of a wanky connection, and then in a moment it will become red. And the nice thing to see here is that the arrow from the vehicle management API service to the vehicle management API deployment is still green.
Yeah, because it's the virtual service that aborts a connection. Right?
My actual service. So if I would now have another application that calls this same deployment but through another endpoint, it will just be up and running.
Because you can just create two services.
You can create multiple endpoints.
The virtual service around one of them.
Exactly, yeah.
Nice.
And if you think about these kinds of constructs when you're designing your application, your architecture, there's lots of stuff that you can do now on this level that we before had to write lots of stupid code for. And this is complex code, and this is very hard to test.
Yeah.
But this way you can just inject some boo-boos into your architecture and see how your application reacts.
Very cool.
And of course, you don't have to do it in production. You can also
Yeah.
do it on a test environment. So that's about it. That's what I wanted to show you. These are some links if you want to get to the Kubernetes documentation. Istio is also very nicely documented, so go there. And if you want to play with this application, and I've described this with a wiki, go to my GitHub page and download all the code, and then you can play with this stuff yourself.
Cool.
So, that's it.
Yeah,
That's
very
what I got.
nice. It's really nice how large ecosystem Kubernetes is becoming with all these tooling and stuff built on top of it. It's, well, you make it look really easy to just get a lot of functionality from basically just some YAML files.
Yeah, and for me the biggest plus was that I didn't have to rewrite any code.
Yeah.
It was just, I have some containers and they run, and now I put a big network abstraction layer in between, and I can do all kinds of funky stuff.
Yeah,
So that's pretty
really
cool.
cool.
Yeah.
So there were some alpha tags in the YAML files. I guess Istio is not really up there for production. Or?
Istio is 1.0.
Yeah.
But some of the abilities or capabilities in there are not yet 1.0.
Okay.
So you have to really stay on top of their blog post and their news because it is very much in flux, so to speak. So you have to make sure that you keep that.
So beware when you go into production that you use the stable parts.
Exactly. Yeah.
All right. Well, thank you very much, Edwin.
No problem.
It's a great presentation. Thank you for watching. Hope to see you next time. Bye bye.
Later.